Welcome to this tutorial where we are going to discuss calculus, and the topic which we are going to cover under calculus is differentiation by first principle. So let's try to understand differentiation by first principle. Okay, so we're looking at differentiation by first can just use that by first principle. So what formula do you use when you are trying to differentiate by first principle? So when differentiating by first principle, you need to use a certain formula. Let's say you want to differentiate this function f of x. So this will be equal to limit as h approaches 0. Then you say f of x plus h. Then you subtract the function itself divided by h. So this is the formula you need to use whenever you want to differentiate by first principle. Okay, so let's have a question. Let's say f of x is equal to 2x plus 1. Okay, so differentiate using first principle. How can you differentiate this? So I'm going to say derivative of this function. I'm using f prime to show derivative will be equal to, first we write the formula, limit, okay, limit as h approaches 0, then f x plus h, like that, then minus f of x divided by h. So what does this mean? So this means that limit h approaching 0, f x plus h, meaning that where there is x, substitute x plus h. So I'll start writing. So I'll write 2. Where there is x, whenever I see x, I substitute that. So x plus h, like that, minus, so plus 1 first, then minus the function itself. The function itself is 2x plus 1. Then everything is over h. So let's now find the derivative. So this will be equal to, I can multiply 2 by x, so I'll say limit, this will be equal to limit as h approaches 0, then I'll say 2 multiplied by x is 2x plus 2 multiplied by h is 2h, then plus 1, then this will be equal to negative 2x minus 1 over h. I can now cancel out what is common. 2x and 2x will cancel out, and 1 minus 1 is 0. So I'll have limit as h approaches 0, I remain with 2h over h. I can divide h over h, which is equal to 1, so the answer is just 2. So meaning that the derivative of that function f of x is equal to 2. It was 2x plus 1, right? So this is the answer. It is just 2. Let's look at another example. Let's say I have f of x to be equal to 3x squared plus 4. What is plus 4x? What is the derivative of this function? So the same procedure. So f prime of x will be equal to limit as h approaches 0, then I'll have fx plus h minus f of x over h. Then I can do the substitution, so it will be limit, okay, so I'll say limit as h approaches 0. We'll write the function. In fact, let me write it this side so that I create space. Okay, so I'll say 3, where there's x, whenever I see x I substitute x plus h, so it will be x plus h square like that. Then it is plus 4, wherever I see x I'll substitute x plus h, then minus the function now itself, which is 3x squared plus 4x. Then everything is over h. Okay, then I can evaluate this. So I'll say what is x squared multiplied by 3. So I'll have limit as h approaches 0. This will be equal to 3 multiplied by x squared. The short way of following this, you just say x squared, then plus x multiplied by h multiplied by 2, that is 2xh. Then you say plus h squared. Okay, then plus 4 multiplied by x, that is 4x, plus 4 multiplied by h, that is 4h, then minus this will just be 3x squared, then minus 4x. Okay, then everything is over h. Let's now see how we can, so this will be equal to limit as h approaches 0. 3 multiplied by x, it will be 3x squared. 2 multiplied by 2xh, it will be 6 actually. That will be 6xh. 3 multiplied by h squared, so plus 3h squared, then plus 4x plus 4h minus 3x squared minus 4x. Okay, then I'll say over h. Something which is similar, 3x squared and 3x squared can cancel out, so that we reduce something. 4x and 4x minus 4x can cancel out, so what we are going to remain with is this. So we're going to remain with limit as h approaches 0, so we'll remain with 6xh plus 3h squared. What else is there? Then plus 4h, of course, then over h. Can get rid of this, so what we are going to have is equal to limit as h approaches 0. So I can do some factorization here. What is common? H. So I can factorize h, then I'll remain with 6x plus 3h, okay, then plus 4 over h. Then where h and h can cancel out, so what I'm going to have will be equal to, this will be equal to limit as h approaches 0. So 6x plus 3h plus 4. I can now substitute where I say h. Whenever I substitute, forget about the limit. So it will be 6x plus 3, where there is h0 plus 4. So this will give us 6x plus 4. So this is the derivative. So this is where we end with differentiation by first principle. In the next session, we are going to do differentiation by first principle of trig ratios. How to differentiate sine using first principle, cos using first principle, the trig ratios. Okay, thank you for watching.